Hello all, let's start section 4.3. In 4.3, let's talk about the graph of tangent and cotangent function, their normal graph, and after that it's a kind of short lecture, and after this we will talk about transformation of tangent and cotangent. To start with the graph of tangent and cotangent, let's focus on this relation. Tangent of angle theta is equal y over what? Over x. If we focus on our unit circle on the left side of my screen, let's see first where y, our value of y becomes 0. Because tangent is a function that it's a ratio, right? Let's see where first y is 0 in our unit circle. If you start from this point, from 0, you see y is 0 at when angle is 0. And you see, if I plug in here 0, 0 over a number gave me 0. It means at 0, the graph of tangent has an x-intercept, which is 0, 0. Correct? Let's see where else the tangent y is 0. If you look at your unit circle, the other places 180 or pi. You see here you have another 0. Then you can mark your pi also as what? As a 0. Correct? Now, tangent has zeros at y, which is 0, and pi. Correct? Also, let's look for this relation. Let's see where y is actually becoming 0, correct? Well, where x is becoming 0. After that, after we find our zeros, now we are looking where x is 0. If you see your unit circle at pi over 2, x is 0. And you see, if I put in this relation x0, whatever the numerator is, because the denominator is 0, in algebra, if you remember, they called it undefined. But when you studied functions, when the denominator is 0, it means you have a vertical asymptote at what? At 0. Correct? Or at pi over 2. Then what I do at pi over 2, I will draw a nice vertical asymptote. Here you go. Let me use the ruler. If I can use my ruler, how to use it, even I don't know. Let's put draw. I'll try to draw it really nicely with my hand. At pi over 2, I get a vertical asymptote. Also, if at pi over 2 I have a vertical asymptote, at negative pi over 2 you get also a vertical what? A vertical asymptote. Now, the period, if you look your unit circle, after every pi, when you do one round, after every pi, when you come from here to here, the tangent of the functions are repeating. Correct? Then easily you can say you can answer the first question. The tangent, the period for the tangent is always what? Always pi. For sine and cosine, it was 2 pi. But for tangent, the period is only what? Pi. Correct? Now, let's see what's happening in negative pi over 4 and positive pi over 4. Let's see first what is pi over 4. At pi over 4 here, at this angle, Radical 2 over radical 2 divide by radical 2 over radical 2 gives you what? 1. Correct? If I mark here as a 1, you get a point here. And of course, at negative pi over 2, it gives you what? Negative 1. Here positive 1, here negative 1. Correct? Now, if I want to connect, if I connect all these points nicely, this graph is kind of the shape of cube function, but not exactly like a cube. You can graph the graph of tangent. Correct? Now, and where is my vertical asymptote? If I want to draw more than one period, your vertical asymptotes, you see, it happens in pi over 2 plus what? Every k pi. You go another pi from here to here, you have another vertical asymptote. It means you get another vertical asymptote at 3 pi over 2 if you want to draw. If you add here on this side, you get another one at negative 3 pi over 2, you get another vertical asymptote. Correct? X-intercept always happens at 0 plus what? K pi. These are really important information that you have to remember. You see, always x-intercept happens at 0, and if you add another pi from here, from this red point to this red point to pi, from 0 to pi is 1 pi. You see, always 0 happens at where? At 0 plus k pi. Correct? Now, if you look for the value of 5 pi over 4 in your unit circle, correct? 5 pi over 4, the value of 5 pi over 4 is also negative radical 2 over 2 and negative here. This, I'm talking about this point, negative radical 2 over 2, which gives you a positive 1. And at 3 pi over 4, let's find 3 pi over 4 here. You see, it gives you the opposite. It gives you a negative 1. Opposite inputs, you see, gives you opposite outcome. It means your graph is what? Your graph is an odd function. Sorry, my hand is shaking. It's really a bad graph. I will redraw it. I don't like this graph. It's an electric pen in my hand. It do crazy stuff always, like this. I need to clear and I need to redraw. This will be another graph of tangent, another period. Correct? Let's answer now these questions. Domain. The domain of your function is all real numbers, but you see, x cannot take where? Pi over 2, because at pi over 2 you have a vertical asymptote plus what? K pi. And every pi over 2 plus k pi, you have a vertical asymptote. Range, of course, you see from negative infinity to where? To positive infinity. Your function is odd because opposite inputs gives you opposite outcome or output. That's why your function is odd. What else to answer? Vertical asymptote. You see, when you graph only one tangent or one period, your vertical asymptotes are happening at the end of the period. Correct? Make this note, it's really important. Vertical asymptote at the end of period. Always it's happening. Because you know, soon we will do transformation, your period is changing, it's not always pi over 2. You have to remember that your vertical asymptote always happens at the end of the period. X-intercept always happens where? At the center of your period, correct? At the center of period. Negative 1 and 1 happens at quarters, respectively. It means in the first quarter, as you see, negative pi over 4 is your first quarter. At negative pi over 4, you have negative 1. At the second quarter, which is pi over 4, you have positive 1. Okay? That's why I told you respectively. It's negative 1 and 1. It's happening at negative pi over 4 and positive pi over 4. Correct? This is all about the graph of tangent. The period is pi, but remember, later when I do transformation, I'll explain to you, the graph of tangent is kind of tricky because the period doesn't start from 0. Actually, you see your period starts from negative pi over 2 to where? To pi over 2. And from negative pi over 2 to pi over 2, if you count, it's only 1 pi, right? From negative pi over 2 to pi, it's only 1 pi. From here to here, it's 1 pi, correct? But the graph starts from negative pi over 2. Half of the period is on one side of the 0, half of the period is on the other side of the 0. Later, when we do transformation, I'll explain to you how to choose your period, correct? How to mark your period. Same way, we can do the graph of cotangent. Correct? Same way, we can do the graph of cotangent function. Let's talk about f of x equals cotangent of x. Correct? Again, if I draw here my coordinate system, correct? I'll mark here, for example, as a pi over 4. Next one, of course, pi over 2. Next one will be, of course, 3 pi over 4. And next one will be what? Pi. And also I can do this side for you if I wish to. Negative pi over 4. Same numbers, but with negative pi over 2. Negative 3 pi over 4. And negative pi. Correct? What happens with cotangent? We know cotangent of theta equals x over what? Y. It's the reciprocal of tangent, correct? Now, easily I can say, wherever that I had vertical asymptote for tangent, those becomes the zeros for what? For cotangent, because they are the reciprocal. Or easily in unit circle, you can see that where our cotangent becomes 0, it means where x is 0, x is at pi over 2, 0, and negative pi over 2, correct? Your x is at pi over 2, 0. Also at negative pi over what? Pi over 2 is 0. Correct? Wherever you have 0 for your tangent, zeros becomes vertical asymptote for cotangent. I had 0 at y-axis, correct? Here for tangent you had a 0. Now your y-axis actually becomes what? A vertical asymptote. At pi you had 0 for tangent. Now at pi you get another vertical asymptote for cotangent because they're reciprocal, right? When you learn tangent, cotangent is easy because it's the reciprocal. At pi over 4, if you flip at pi over 4, you get 1. At 3 pi over 4, which is the next quarter, you get negative 1. It means if you graph, the graph of cotangent is like this. Everything is the same, like you see everything is changed, only the shape flipped. Here in the first quarter, at the first quarter you always get positive 1, here negative 1. Your graph will be like this. Correct? Some notes, they are the same as tangent, still the domain is the same. Domain is all real numbers, but this time x cannot take what? 0 plus k pi. Because you see your first vertical asymptote is at 0. And if you add a pi on it, and every pi you get what? A vertical asymptote. That's why it's not in your domain. Range is the same. Ranges from negative infinity to positive infinity. Your function is still odd. It's an odd function. Period is still pi. Correct? X-intercepts happens at pi over 2 plus what? Pi. And vertical asymptote happens at pi at 0 plus k pi. Correct? Or you can put these notes for x and vertical asymptotes. They are important. Vertical asymptotes at ends of the period. Again, same thing. Ends of period. One cycle, one period that the graph completes. You see on two sides of this cycle or period, on this side and this side, you have always vertical asymptote. Correct? X-intercepts at center of the period, same thing as tangent. The only thing that's changing, you have 1 this time and negative 1 at quarters. Quarters. For tangent, it was negative 1 and 1. For cotangent, 1 and negative 1. Correct? This is all about graph of tangent and cotangent. In next video, I'll cover for you how to transform or how to do transformation of tangent and cotangent graph. I'll stop the lecture here. See you all in section 4.4, I think, which we cover 4.3 part 2, which I will cover also the transformation for tangent and cotangent.